Hello, my dear NEET warriors. Welcome aboard to the one and only Unacademy NEET English channel. And this is your physics educator, Captain Shreyas. And I'm going live for all of you for solving problems based on circular motion, work power energy. They are NCERT based, specifically designed for NEET, and also some of them are PYQs or PYQ inspired. So these are top collection of problems, and I'll be also giving you my own questions out here in this particular sweet, short, crisp session. All right, so get set go. Make sure you have your rough book outside, make sure you have pens outside, and make sure your mind is active, fresh for this particular session with me. And before we go ahead, make sure you have smashed the like button, show your support, show your love. I want every student out here to go ahead, smash that like button right now, right there. And also, if you have not yet subscribed, subscribe to the channel. The entire PDF will be available on the Telegram channel. All right. Good evening, Harvey, Sunlight, Kirtana, Raghui, PG, Vijay. Good evening. Good evening. When will I teach these chapters? I will be teaching it later on. All right. Mohan Raju. Good evening. Avengers have assembled. All the Avengers, let me know if you have assembled, actually, because many of the Avengers students had also requested for this particular session. So I want to know all the Avengers out here who are already studying under me in the Avenger batch, and all the Conquerors also have assembled. So Conquerors, Avengers, assemble. It's time to begin the class. And here comes the first question up on your screen. Centripetal acceleration is, we know that when a particle goes in a circular path with certain velocity, there is an acceleration which is directed towards basically the center. Basically towards the center. Is it a constant vector? Is it a constant scalar? Is it a magnitude changing vector? Is it not a constant vector? Well, a lot of people think the magnitude, which is basically just given by V square by R. R is constant, V is constant, so AC is constant. No, it is not mentioned whether it is uniform circular motion or non-uniform circular motion. In non-uniform circular motion, speed changes. If speed changes, V square by R will change, AC will change, so magnitude can change. Not just that, once it goes from here to here, don't you see the directions are changing? So direction also changes. Direction also changes. Velocity may change. Hence, even acceleration magnitude may or may not change. May or may not basically change. So you cannot say for sure what happens, but I know for sure as a vector it is not constant. Hence I shall mark option D. How many of you have said D? I know some of you said C before because you thought it is a magnitude changing vector, or some of you even thought about B, that sir, the magnitude is constant. No. Magnitude may not be constant. All right, is that clear? Only in uniform circular motion speed is constant, magnitude will be constant. Right? So that's this particular question. Very tricky question. Many of you fell for the trap. Here comes the next question up on your screen. A body executing uniform circular motion has position vector and acceleration vector along the same direction, opposite direction, normal to each other, not related at all to each other. What do you think is the answer for this particular question? Is it option A, B, C, D? I want everybody spamming the chat box right away right now. What is the answer for this particular question? Is it A, B, or C, or D? All right. So correct answer for this, remember, because it is uniform circular motion, clearly mentioned over here, position vector and acceleration vector. As you go in a circular path, you will see if this is the position vector of that particle, then the acceleration, centripetal acceleration will be here, and this will be also the total acceleration, because tangential acceleration will not be present, because it is clearly mentioned that it is a uniform circular motion. So the acceleration is exactly, you can say, opposite in direction to the position vector, radius vector, radial vector. Exactly. There is no tangential acceleration. So the total acceleration is the centripetal, and centripetal means towards, obviously, the center of the circle. Hence, that is the answer. Right? Beautiful question coming up on your screen, coming up now. Here it is. a stone is tied at the end of a 100 centimeter long string, you can say, and it is whirled in a horizontal circle with a constant speed. Stone makes 14 revolutions in 22 seconds. Then the acceleration of the stone is how much? Hello Shronesh, good afternoon everyone out here. Start solving the questions coming up on your screen. A power-packed problem solving session on work, power, energy and circular motion, which is your class 11th physics topic for your NEET examination. So all the 11th standard, 12th standard students, all the NEET conquerors or the NEET avengers or the NEET energized people, assemble in this power packed session, guys. All right, and make sure that your friends are also online right now. Okay, so like I can see over here, because the particle is going in circular motion and there is some radius, there is going to be some centripetal acceleration. I think I can find omega from here, because omega is nothing but 2 pi divided by the time period, where the time period will be, see, 14 revolutions in 22 seconds. So for one revolution, what is the time period? So 22 seconds divided by 14. So if I substitute it over here, this will be 2 pi divided by, instead of t, you put 22 and then you get 14 on the top. Why do I need this? Because in order to find centripetal acceleration, I have the formula v square by r, or I can use omega square r. I will stick with this because omega has been found very easily over here. So centripetal acceleration will be omega square. Remember, this whole thing is omega. So 2 pi by 22 into 14 whole square into the radius. 100 centimeters is basically 1 meter. So hence it is just 1 over here. Now instead of pi, I can just write it as 22 by 7. This 22 remains here and this 14 remains here. Into 1 is 1 only. So 22 cancels. 7 goes with 14 2 times. 2 2s are 4. So it will be 4 square, which is basically 16 meters per second square. It is option A, I believe. Yes, it is. Exactly. Option A. Perfecto. Perfecto. Yes, Shronesh, why not? This is for all the students across the country. And you're from Telangana, trust me, there are many students from Telangana. Okay? Many students from Andhra. Okay? Fine? You can definitely watch it. Alright, moving on to the next question coming up on your screen. There are two questions, we'll solve both of them together. In assertion reason, usually the options are, option A says both are correct and the reason is the correct explanation. Option B says both are correct, reason is not the correct explanation. Option C will say assertion is correct, reasoning is wrong. Option D will say both are wrong. Usually these are the options. So look at the first question and then the second question. Centripetal acceleration is always directed towards the center of rotation of a body undergoing uniform circular motion, which is definitely correct. The centripetal acceleration is always directed towards the center. So this is correct. Centripetal acceleration is a constant vector. Definitely not. You can see the magnitude, the direction can change. So centripetal acceleration is not a constant vector. So assertion is correct, reasoning is wrong, 100%. Look at the next one. Uniform circular motion is an accelerated motion. A lot of people believe that when you have uniform circular motion, the speed is constant. But that's not true completely, because even if the speed is constant, so a lot of people think acceleration will be zero. No, that's not true. Because even if the speed is constant, what happens is the direction changes. The direction changes. So the moment the direction changes, you can see that the vector will change. So is an accelerated motion? Definitely. Because acceleration means there will be change of velocity, and velocity changes, that means here direction is definitely changing. That's why I can say it is an accelerated motion. Direction of the acceleration is parallel to the velocity vector. No, it is in fact perpendicular. So assertion is correct, reasoning is wrong for both the statements. Yes, assertion is true, reasoning is false. Yep. Is that right? Perfect. Perfect. Everybody with me? Understood? So uniform circular motion is accelerated motion in spite of the speed being constant, because the direction changes, the vector changes. That's how it works. Let's try the next question coming up on your screen, my dear students. There is a motorcyclist. He rides around the well of a vertical wall. He rides around the well of a vertical wall and he does not fall down while riding. You might have seen this in a fair or maybe at some stunt show or something like that on TV, where there is a motorcyclist and who is going in a death well, right? So that well maybe like this, say for example, and that person might be riding the bike like this. Okay, he's going like this. Just imagine this is vertical, something like that, where you might have a bowl like structure which is like this, and that person is going in this particular path. So what might be happening? If you see, this is the surface, the bike person might be over here. This is where the bike person might be. Okay, this is where the bike person might be. The road curves like this, remember that. The forces acting on that particular person will be one weight like this, mg, and there will be one normal. There must be some force to balance mg, and that will definitely come from friction. So the frictional force balances the weight. Yes, that is option D. That's option D, because the upward acceleration is not there. There is no motion in the upward direction. So that means the friction has to balance mg. There is no other force which can balance it. Exactly. Yes. I hope this is clear. I hope this is clear. Even with marbles you can observe. Definitely, Anish, if you take a marble and throw it in a bowl, you will see that the marble goes in a horizontal circle, and yes, the friction is the one which balances the force perfectly. Awesome. Thank you, CM Ahmed. Thank you. Thank you. Moving on to the next question up on your screen, and here it is. Look at this question. What does it say? The coefficient of friction between the tires and the road is 0.1. The maximum speed with which a cyclist can turn in a radius of 3 meters without skidding. So whenever you are turning in a curved road, if there is some radius, there is always some maximum speed associated with it, with which you can go without slipping, and that is mu rg's root. Root mu rg is the maximum speed with which you can travel on a curved track. Now the value of mu is definitely given to me. It is basically 0.1. The radius is 3, g is 10. 10 into 0.1 is 1. So just root 3, which is 1.7 meters per second. That's barely anything. But yeah, that's a very small speed. But that's the answer. So we'll have to mark it. We have no choice. Of course. That's the correct answer. Everyone, how many of you wrote B? Very good. Awesome. 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 Great, great. Concentrate, concentrate, Buddha. Concentrate. I have taught these chapters in the Avenger batch, in the Energized batch. If you have not yet joined that, make sure you join it. You can get the replays also. You can get all the complete details of this particular chapter. Moving on to the next question up on your screen. A circular racetrack of radius 300 meters is banked at an angle of 15 degrees. The coefficient of friction between the wheels of a race car and the road is 0.2. Then the optimum speed of the race car to avoid wear and tear of the tires. Now, in case of a flat road, the maximum speed is mu rg, root. But I want to increase that speed. So what I do is I tilt that road slightly. Basically that is called banking. And then the maximum speed with which I can go definitely increases. That's why you see the roads, the railway tracks, etc. are banked, or they are inclined to, negotiate the turn with a much higher speed. But it might happen that you don't want to go with maximum speed. You want to go with a decent speed by making use of very little friction. When you use very little friction, basically you are having very little wear and tear of the tire. So that's exactly the case. Very little wear and tear, that means friction is 0. That means the speed is optimum, and the optimum speed formula is root of rg tan theta. It is root of rg tan theta. Remember the maximum speed formula. The maximum speed formula is basically root of rg. It is tan theta plus mu upon 1 minus mu times of tan theta. So that's a big formula for maximum speed, but that's not what has been asked. What has been asked is your optimum speed. So substitute everything that you know over here. The radius of curvature is basically 300, G is basically 10, tan theta is basically 0.27. Now if you notice, I can shift the decimal 2 times because of these 2 zeros. I can shift the decimal here. So 27 into 3 is nothing but 81, and right, and I have 0 over here. 81's root is basically 9, and 10 remains inside the root. We have no other option but to mark option B. B for Bombay, B for bananas. Exactly. Hello, Aktishta Navin Raj. I hope I have pronounced your name properly. Akshitita. Yes. Yep. Very good. Very good. Awesome. Sivapriya, Mohana, Kartika, Krishna, Samishir. Very nice. Very nice. Awesome. Awesome. Great. Let's move on to the next question coming up on your screen. And here it comes. Here it comes. So my dear warriors, I have taught this chapter in the Avenger batch and in the Energize batch. Please keep that in mind, okay? So a body is being raised to a height h from the surface of earth. What is the sign of work done by applied force and gravitational forces respectively? Is it both positive? Is it negative positive? Is it positive negative? Is it negative negative? All right, let's try to understand. If you take a body and if you take it up like this, then once you are taking it up, that means the displacement is in the upward direction. The forces acting on it are the force by your hand or the person on it, that means the normal force, and there will be the weight force or the gravitational force. We all know when the force is in the direction of displacement, then the work done by it is positive. When the force and displacement are in opposite direction, then the work done is negative. So therefore, the work done by normal will be positive in nature. The work done by the weight or gravity will be negative in nature. So answer will be positive and negative. Positive and negative. The applied force means normal. Gravitational force means the weight. That's exactly what it would be. This W is the work. Alright? How many of you wrote B? Wow, the chat box is filled with B. Awesomeness. Proud of all of you. Moving on to the next one coming up on your screen, and here it is. A particle is acted upon by a constant force 4I plus j minus 3k, 3I plus j minus k, displacement from this to this point, the total work done by all the forces. Pure vector dot product problem. You can see there are two forces over here. First of all, find the net force. The net force will be just the addition of both of them, 4I plus j minus 3k. You also have 3I plus j minus k. So when you add both of them, you will get 7I plus 2j minus 4k. That is the net force. That is the net force. Also find the displacement. Displacement is always final minus initial. This is final, this is initial. This is final, this is initial. Final minus initial. So 5I minus I is 4I. 4j minus 2j is 2j. K minus 3k is basically minus 2k. I hope that is fine. This many meters is the displacement. Last step would be work. Work is basically force dot displacement. The dot product of force and displacement gives you work. So force is basically 7I plus 2j minus 4k dot product with your 4I plus 2j minus 2k. Now you notice 7 will multiply with 4, 2 will multiply with 2, minus 4 with minus 2. That's how dot product works. 7 4s are basically 28. 2 2s are, that is 4. Minus into minus is plus. 4 2s are basically 8. 4 plus 8, 12. 12 plus 28 is nothing but 40. 40 joules is the answer. Yes, it is option B. B for banana. Banana is the answer. How many of you wrote bananas? Very nice. Ardika, Gopi, Shamsher, Kashish, Priya, Dr. Saranya. Very good. Awesomeness. That's the correct one. Cool. So whenever forces are given, you take the net force. Whenever positions are given, you subtract them to get the displacement, like we have done over here, because that's how displacement is. It's final minus the initial position, right? Okay. Moving on to the next question coming up on your screen. The force acting on a body is inversely proportional to its speed. Okay. Then the kinetic energy is linearly, inversely, constant, whatever. So clearly mentioned, the force is inversely proportional to its speed. Force is inversely proportional to the speed, right? Now just play around with this. Force is nothing but m times of a, 1 by v. Instead of that, I'll write constant by v. Replace the proportionality with equality. That's all I've done. Now just rewrite this. Acceleration is nothing but dv by dt into m is equal to constant by v. Shift the terms. v dv into m is equal to c times of dt. Now basically you all have to do is just integrate both sides. The moment you integrate both sides with limits, you will see this will be nothing but mv square by 2 is equal to, correct? V's integration is v square by 2. X raised to 1's integration is x raised to 1 plus 1 by 1 plus 1, means x raised to 2 by 2. This will be nothing but c into t. Essentially I am integrating this from 0 to v, this is 0 to t, right? So what do I get? This is nothing but kinetic energy. Kinetic energy is c times of t. That means kinetic energy is directly proportional to time. Again the answer is B. No, it is not. It is not B. It is A. It's linearly related to time. So option is A. Perfect. Wow, you guys are quick and very good. Nice to see all of you. Yes, this is a practice quiz. Definitely. Yep. Very good, Samsher, Krishna, Divya, Vector, Azhari, Omar, Samaira. Very good, Susmita. Very good, Mudolu. Very good, Priya. Very good, Kashish, Krishna. Awesome. Moving on to the next one on your screen. In a non-relativistic regime, means normal mechanics, don't get worked up or nervous. So what is this non-relativistic thing? Don't worry, basically normal mechanics. If the momentum is increased by 100%, then the percentage change in the kinetic energy will be how much? Momentum is increased by 100%. See, understand the meaning of it. 100% of momentum, let's say if initial momentum is P, 100% of P means P. So increased by 100% means you have increased by P. So can I say final momentum is original momentum plus the increase. That means it will be 2p. It is basically 2p. Everyone with me? Now, how is momentum related to kinetic energy? We all know kinetic energy is basically, I would say, just equal to p square by 2m. Basically, it is directly proportional to the square of the momentum. Now, if momentum is made 2 times, the square will be made how many times? 4 times. So kinetic energy has now become 4 times. So if initial kinetic energy was K, I would say the final kinetic energy is basically 4K. So what is the increase of kinetic energy? 4K minus K, which is basically 3K. Basically 3K is nothing but 300% of the initial kinetic energy. That's it. 3 times means 300%. So that's why the answer is C. Lot of students, I know, they end up marking 400 because they see it becomes double, that means 4 times. So they think 4 times means 400%. Yes, the final energy is 400 times of the original energy, or sorry, 400% of the original energy, but the increase, the change is 300%. So 100 laddus became 400 laddus, but the change of laddus is 300. Understand that. That's how this works. Okay, a lot of students I know have made mistakes in these kind of questions. Moving on to one more question coming up on your screen, and here it is. You can see that this is a force versus displacement or position graph. It starts from 10, comes to 0 at 6 seconds. From 6 to 10 it is minus 5. From 10 to 14 it is plus 5. From 14 to 16 it is minus 5. Question is, if the original kinetic energy was 25 joules, what is the final energy at 16 meters? From this particular question, you should understand, since initial is given, final is asked, graph of force and position is given, it clearly is a question on work kinetic energy theorem. And we all know that area under force versus position basically gives you work, and work kinetic energy theorem says that work is nothing but the change in the kinetic energy. So basically just find the area under this graph. If you notice, what is the area of this triangle? Half into base is 6, into height is basically 10, so this is nothing but 30. Okay, next, what about this area? This will be negative because it is below, so this height is basically 5 and the width is basically 4, so this will be nothing but minus 20. This area, width, you can see it's above, so it is positive, width is nothing but 4 and height is basically 5, so again it is 20. What about this one? It's negative because it's below, width is nothing but 2 and height is nothing but 5, so basically it is minus 10. So what is the total work done? What is the total work done? The total work done will be 30 plus 20 minus 20 minus 10, so basically it is nothing but 20 joules. And this 20 joules is the final kinetic energy minus initial kinetic energy, correct? That's what it is. So final minus initial is how much? 25 is equal to 20. So final will be 20 plus 25, which is 45 joules. 45 joules is A for Ames. A for Ames. No, it is not D. It is A option. Very good, Erapa. No, it is not D. It is not B. It is option A. Yep, many people again make mistakes over here. Some or the other thing, maybe you miss the sign, or maybe you make some silly mistake while calculating the areas, or who knows, you just get stuck over here. So it has two concepts. One is the area under the force displacement graph gives you basically work, and the second thing is that the work gets completely converted into the change in the kinetic energy. Initial was given, final was asked. That's all. All right, is that okay? Yeah, some of you forgot the plus, some of you forgot the sign, so many things. Next question. There is a block of 10 kg is moving in the x direction with a speed of 10 meters per second. It is subjected to some force of this much. During its travel, the final kinetic energy will be how much? Okay. Instead of graph, here the force as a function of x is given. And now, same thing is asked, what is the final energy? Immediately it should click your mind that yes, this is a question on work kinetic energy theorem. I know the initial, I want to find the final, so I need the work. How do I find the work? Well, if graph was given, I would just take the area. But here no graph is given, I have been given the equation. So what is the substitute for area? That's integration. So we'll integrate, right? So first find the work, my dear warriors. Work is basically integration of force with respect to displacement from initial to the final position. So the force is minus 0.1, I'll put it outside the integration, x dx starting from 20 meters to 30 meters. Perfecto. So this will become minus 0.1. X's integration is x square by 2. So that means this will be 30 square by 2 minus 20 square by 2. So if you want, you can just take 10 square outside, so that will become 100, and this 2 also outside. So I'm just left with basically 3 square minus 2 square. Now 0.1 into 100, 0.1 into 100 is nothing but 10. 10 by 2 is basically 5. So I just put 5 over here. 3 square is 9, 2 square is 4, 9 minus 4 is basically 5 again. So this is becoming nothing but minus 25 joules. That's the work done. But that's not the end of the story. You have to find the final kinetic energy using work kinetic energy theorem. This is work kinetic energy theorem. So work done minus 25. Final, I don't know. Initial, where is it? Oh, I don't know initial, I have to find it out. So it will be half mass is 10 into speed is basically 10. So 10 square. So therefore, the final kinetic energy will be half of 10 into 10 square is basically 1000 this remains as it is, minus 25. And just taking it on the other side, so this entire term becomes positive. So this will be 500 minus 25, which is 475 joules. That should be the answer, which is D for doctor. How many of you written doctor? How many of you written doctor? Awesome. Gopika, we have done almost till, Newton's laws was done last lecture. Next week we are going to start magnetism, all of that. Current electricity was done. And guess what, my dear students, I am keeping a special class on voltmeter, galvanometer, ammeter and potentiometer. Basically the electrical instruments as a separate class on Tuesday afternoon, maybe around 3-4 o'clock. So make sure you do not miss that. All right. So that's the class on Tuesday, and Wednesday we'll be having magnetism class, and then the next week we'll be doing, the 11th standard, 12th standard combined again. Right, that's what we are going to do. So beautiful question. We had to integrate instead of finding the area, and we had to again use work kinetic energy theorem. Moving on to one more question coming up on your screen. The negative of the work done by the conservative internal forces on a system equals to the change of. Very interesting question. Come on, my dear students. This is a standard definition. The negative of the work done by the conservative internal forces is standard formula. Work done by the conservative forces, and you take minus of that. That is your change in your potential energy. Yes, delta U, which is C for captain stress. C for captain. C is the correct answer. Not total, not anything else. And in fact, from this only we get the relationship F conservative is basically minus du by dr, or du by dx, or du by dy, or du by dz. Right? So from this only we get this particular relationship. Moving on to the next question coming up on your screen. Match the following. Recently it was said that expect new pattern or new types of questions in NEET 2024. Like they have started already experimenting with fill in the blanks. Assertion reason was there. Quite quite a decent number of questions were there this time alone. So expect match the following also, in a way that it feels like a single choice question only. Look at this, options are there over here as to which particular side will match with what on the other side. So everything is given in the form of options. So yes, match the following can also come. So we need to be prepared for that. Fill in the blanks, even true and false, or even match the following. All these things are very, very probable. Okay, when you solve these kind of questions, where you have been given a situation, in this case a bob of mass m is suspended, so that you impart a horizontal velocity at the lowest point so that it completes the vertical circle. Whenever you have a string like pendulum, and you have to impart it certain velocity for it to complete the circle, the minimum speed is root of 5 gr or L, whatever it is, and then this thing goes here, and at the topmost point the speed does not become 0, it is still present, it is basically root gl. If you notice, there is only one such option which matches like that. Look at that, velocity at point A, the velocity at point A, which is V0, is going to be root 5 gl. So A will definitely match with R, and there is only one such option. And if you want to confirm it again, take the topmost point, which is basically C point. At that point the speed is basically root gl. So for C the answer is Q. Perfect. You don't even have to check the second thing. If you check only one, you see that everything else need not be checked. You can just skip it and you get the correct answer. Exactly. So this is the trick which you will use in match the following. You are not going to sit and waste your time and solve the entire match the following. That is just a trap to ensure that students lose time in such questions. But actually you just need to check generally one or two options. In the worst case, you will have to check all the 4 options. All right, but that will be then a difficult question, I would say, right, from the NEET perspective. Moving on to the next one. There are 2 springs, constants given, stretched by the same force. They will have potential energy in the ratio of. C for capital was the answer, yes. So they will have potential energy in the ratio of. Spring potential energy is given by half kx square. It's clearly mentioned the force is same. So immediately it struck me that I can do a small manipulation like this. I can write it as k square x square by k. Nothing is lost. It's the same thing. Just multiply and divide by k. Now what is this kx? What is this kx? If you notice, that is basically the force, and I'm squaring it and divided by k. Now force is clearly given to be same. So can I say potential energy is inversely proportional to the spring constant? So can I therefore say U1 by U2 is K2 by K1? What is K2? 2000. What is K1? That's 1000. So what is the answer? 2 by 1. 2 by 1, that's option A. A for Ames. Exactly, Kashish, Sivapriya, perfecto. That's the answer. So this manipulation was very important for you to get the answer. It's not like without this manipulation you cannot get it. You can get it, but it will be quite lengthy. And the reason why the manipulation struck me is because I was able to visualize both the formulas. Potential energy is half kx square, and I also know spring force is basically kx, magnitude wise. Magnitude wise, spring force is kx. Don't put minus kx, that is meaningless. Understand that. I have told you this in Newton's laws. Alright, moving on to another question up on your screen. Body is at rest. It undergoes one-dimensional motion with constant acceleration. The power given to it at time t is proportional to. The power delivered to it at time t is proportional to. It is going with constant acceleration. How do I do this? Power is related to rate of change of work, or I can also write it as force into velocity. So maybe I go with that. Power is nothing but force into velocity. And now if you think about it, force is nothing but mass into acceleration, and clearly mentioned that it has constant acceleration. So acceleration, if it is constant, we know V is equal to U plus AT, and it starts from rest. Initially it is at rest. So therefore V is equal to A into T. Interesting. Substitute it over there and see what do you get. Instead of force I will write MA, and instead of velocity I will write AT. So this will become M into A square into T. So power is directly proportional to T, because mass is constant, acceleration is given to be constant. So the correct answer should be B for bananas. B for bananas. No, it's not A. No, it is not A. It is option B. Be careful. It is option. Yes, it is option B. Correcto. Moving on to the next one coming up on your screen, and here it is. When water falls from a height, okay, of 60 meters at the rate of 15 kg per second on a turbine, there are some frictional losses. 10% of them is lost. How much power is generated by the turbine? Okay, let's understand. See, there is water over here. Okay, it falls on, let's say, a particular turbine like this, and that turbine generates basically electricity. Turbine generates basically electricity. 10% of it is basically lost. First of all, this thing would have potential energy. That potential energy will get converted into kinetic energy. Out of that kinetic energy, not all the energy goes in electricity, only 90% will go in electricity. So if 100 joules was generated potentially, kinetic wise it will be 100, but when it gets converted into electricity, because of the losses, 10% is lost, only 90 joules is converted as electricity. So I can say the amount of electricity generated, the power which is generated by the turbine, the power generated by the turbine is 0.9 times the power of the water's potential energy, which is coming from the top. So 0.9. Now that power, I can write it as the potential energy mgh divided by the time taken. Now if you notice over here, I already know the value of m by t, which is mass per unit time. It's clearly mentioned as 15 kgs per second. So strictly speaking, this is m by t. So instead of m by t, I write it as 15. G is basically 10. Oh, sorry, this was 0.9. I don't know why it became 0.2. That was a silly mistake. Yeah. and into, what is it? Height. What is the height given? Height is basically given as 60. Is that right, my dear warriors? Yeah. Is that right? Perfect. So what next? 0.9 and 10. I just shift the decimal. So it will be 9 into 15 into 6 into basically 10. Now basically you can say 15 6 are 90. 15 6 are 90. So this will become 90 into 10. So this is basically nothing but 9 9s are 81. So 2 more zeros over here. But that is watts. I can also write it as 8.1 kilowatts. 8.1 kilowatts is option number 4 or D. Yes, that's the correct one. That's the correct one. Awesome, awesome, awesome. Harish, just make sure you first of all join the Telegram group for the test series batch. All right, there is a separate Telegram group. The link has been already shared in the individual sessions of that particular test discussion. All right. Or you can also watch the lecture which was created by Wazim sir sometime back regarding the schedule. So there was a video on test series. Just watch that video, you'll understand the schedule of it. Every week there is a test. Okay, let's go to the next question up on your screen. Force acts on a particle in the y direction. F is in Newton, y is in meter. Work done by the force to move the particle from 0 to 1 meter is how much? 0 to 1 meter is how much? All right. So I think we have to just integrate this because the force is variable. You can see why it is variable. It's a function of y. So I have to integrate this. So here work will be integration of force with respect to y. The force is 20 plus 10 times of y into dy. The y coordinate changes from 0 to 1. 0 to 1. So this will become 20 integration dy 0 to 1 plus 10 integration of y dy from 0 to 1. So this would become 20 into dy's integration is y. So substitute 1 first, then 0 plus 10 into y's integration is y square by 2. So 1 square by 2 minus 0 square by 2 after the limits. So this will be 20 plus 10 by 2 is basically 5. So this will be 25. 25 is option number 4. That's the correct answer. Yep, D. Perfect. Perfect. Awesome. Next, let's go to the next question. Yes, the next question I wanted to give you on my own. Imagine this. If I tell you that U, the potential energy, is given by minus x cube plus 2x plus 4 joules, then can you find the force as a function of x? Then can you find the force as a function of x? The answer for this will come from this formula. Think about it. Minus du by dx. The gradient of potential energy with a negative sign is the conservative force. So use this, you shall get the answer. So basically you have to take the derivative of nothing but minus x cube plus 2x plus 4. So this will become minus of x cube's derivative. X cube's derivative is 3x square plus 2x's derivative is just 2. Constant's derivative is 0. So put that minus sign inside. So it will become 3x square minus 2 Newton. That is the answer for the force. That is the answer for the force. Exactly. 3x square minus 2. Very good, Sivapriya, Mohana. Awesome, Krishna, Rahul, Kashish. Perfect. No, not plus. It is minus. Be careful. You mistook the sign. Be careful. All right. What if I change the question slightly? What if I change the question slightly and I say that the potential energy is x square y joules, find the force. Find the force. In such a case, when there is a variable with x also and y also, then you differentiate it 2 times separately. Once with respect to x, once with respect to y. So if you just figure out fx, it will be minus du by dx. Minus du by basically dx. So it is minus d by dx of this guy. But when you do that, y is a constant, so you can bring it outside the integration. So you can, derivatives. So this will be minus y, derivative of only x square. Similarly, when you find fy, it is minus du by dy. But this time you keep x as constant, keep y inside. So basically x will come outside and you're just differentiating y with respect to y. So this answer will be anyways y into 2x and this answer will be basically minus x square into 1. So the total force will be, this is the x component, so minus 2yx I cap, this is the y component, that means it is minus x square j cap. That is the final answer of the force. That is the final answer of the force. Is that clear, my dear warriors? Is that understood, my dear students? Perfecto. Can we go ahead? One more question coming up on your screen. Taking two situations. Convex up surface, a mass going with certain speed. A convex downward surface, the same mass going with the same speed. Where do you think the normal force will be higher? If I compare normal force here and normal force here, what should I put over here? More than, less than, or equal to? Remember, there will be a normal force like this. Normal force here and normal force over here. Where do you think that normal will be higher? Out of N1 and N2. Think about it and post the answers in the comment section. Post the answers in the chats right away, right now. What do you think? You can even go with feeling. You can also solve it with equations. If you solve with the equation, you will definitely get an answer. If you see, there will be mg weight which is acting down. Many people think normal is equal to mg. No. Think again. Over here, there is centripetal acceleration like this. There is centripetal acceleration like this. If it has to accelerate down, obviously this force should be bigger than this force. Think about it. Mg over here must be more than N1 because mg minus N1 will be MAC. Bigger minus smaller force is mass into acceleration. So N1 is smaller than mg. Here it is accelerating up. Center is up. Centripetal acceleration will be up. So therefore it has to be that N2 is more than mg because N2 minus mg is equal to mass into centripetal acceleration. So if N2 is more than mg and here N1 is less than mg, obviously N2 is more than N1. You can see that right over here. Very nice. Awesome, my dear warriors. Very good, very good. Another kind of question which you might get is something like this. You have a disk and it is rotating with angular speed omega, and you have kept a coin or some block of mass m. There is coefficient of friction mu and it is at a distance of, let's say, r. The question will be to find maximum angular speed such that it doesn't slip. It doesn't basically slip. That's the kind of question you might get. You have to rotate that platform very fast. So even if you rotate it fast, it should not fall out. So the question is, what is that maximum permissible angular velocity? Okay. Now this kind of question, it's very easy to solve via centrifugal force, because we know once you rotate it, this mass is going to experience a centrifugal force, the pseudo force, which is going to be m omega square r. There will be normal and mg like this. There will be normal and mg like this. Who will balance the centrifugal force? Who will balance the centrifugal force? Come on, think about it. Who will balance the centrifugal force? Think about it. Yes, it's the friction. So friction will balance it. And I can say friction is equal to m omega square r. As you increase omega, friction will increase. Once it becomes the maximum value, maximum limiting friction, this omega will also be maximum. Alright. So therefore, it will be nothing but m omega max square into r. Friction max will be mu n. N is nothing but mg. M cancels, cancels. So I'm getting omega max whole square is mu g is on the top, and I think r will go below. So therefore the maximum angular speed is root of mu g by r. Root of mu g by r. Exactly. That's the answer. Perfecto. Perfecto. Good evening, Mamta. Is that clear? So these are the kind of questions you can expect in work, power, energy and circular motion chapter. It's a very important, interesting chapter, and I hope that you do really well in these two chapters. If you want, we will have a separate class as well after some days, but let's get back to 12th standard portions in the next week, and then we'll again come back to 11th standard portions in the week ahead of that. I hope you enjoyed the class. I hope you learnt a lot, and I hope this was a confidence booster class as well. All right, see you guys in the Avenger batch or the Energized batch. If you have not yet joined, please join it, because 31st July is the last date. The batch is going to be closed after that. We are ending it. We are stopping the entry to that batch, because already a lot of portions have been covered, and we do not want that you come up at the last moment. We want you to make that decision really fast. We want you to spend a lot of time with us, because the more time you spend with me and the team, that's when you actually improve. If you come at the last moment, it's difficult. It's just like the patient going to the doctor after, suffering for a long time. You have to go at the beginning only and cure the, problem. So same way, I would love to have you, love to teach you, love to conduct many classes in the Avenger as well as the Energized batch. So make sure you're a part of it. There is a link which is there in the description box. Make the best use of the offer code using the coupon Avenger, right? So that's how you're going to get the maximum benefit on the pricing. All right, so do not forget to leave a comment after the session ends which chapter you want next of 11th standard. 12th standard, I have already told you, magnetism and the electrical instruments is going to be conducted next week. So which 11th standard topic you want, I want it down in the comment section. Thank you very much. Do let me know how you enjoyed this class, and the PDF will be shared on the Telegram channel. Bye bye. Hasta la vista. Take care. This was Captain Shreyas. Thank you for liking.